In this video, we are going to see something about partition technique in distributed database. So before going what is partition techniques, first we should know where these partition techniques are used. These partition techniques are used when parallel computing is needed. Parallel computing is or the parallel machines are quite common and affordable. Databases are growing, increasing largely. Large volume of transaction data are collected and stored for later analysis. Multimedia objects like images are increasing stored in database. You know, every day lots of data is created. Now if we use simple traditional techniques of doing computing, it will take lots of time. So we use large scale parallel database system. Increasingly they used for storing large volume of data, processing time, consuming decision support queries, and providing for high throughput for transaction processing. Now let's us go and focus on our topic today, that is partition technique. Data can be partitioned across multiple disks for parallel I/O. Individual relational operators, this like example sorting, joining, and aggregation, can be executed in parallel because each of them have no interaction between them. If at a certain time if sorting is done, joining can also be done. We don't need to wait for each other because they are independent tasks. So data can be partitioned and each processor can work independently on its own partition. Queries are expressed in high level languages, and so like SQL, because in SQL everything is separated, we can use makes parallelizer easy. Different queries can be run in parallel with each other. Concurrency control takes care of conflicts. Thus database naturally lends themselves to parallelism. As we have seen in this slide, that now when data is working in parallel, we have to see that concurrency conflicts are not happen. If read-write dependency should be not there, if it does happen, then inconsistency and then the data will be lost. So we should see that all the conflicts should be resolved properly, and this will help us that in a very great. It will make the things very easy. So let's go on. What is data partition? Data partition distributes data over number of processing elements. Each processing element is then executed simultaneously with other processing element, thereby creating parallelism. Can be a physical or logical data partition. In shared now in this in the shared nothing architecture, data is placed permanently over the several disks. In shared everything architecture, data is assigned logically to each processor. So the shared nothing architecture and shared everything architecture these are the two types of parallel processing architecture. In this, as it says that in shared nothing, data is placed permanently, and whereas in architecture, data is assigned logically to it. Again, this can be of two types: basic data partitioning and complex data partitioning. In this, we will focus mainly on basic data partitioning. So basic data partitioning, they can again be divided into horizontal partitioning and vertical partitioning. Horizontal partitioning means tuples of relation are divided among many disks such that each tuple resides on one disk. It enables to exploit the I/O bandwidth of disk by reading and writing them in parallel. Reduces the time required to retrieve relation from the disk by partitioning the relation on multiple disks. Okay, now horizontal partitioning, if you take in a practical where we use where clause. So when in the SQL queries, if you use where clause, then conditions are applied. So some rows get deleted. So horizontally the partition is there. Vertical partitioning means taking a single row. Like if we have in a database, we have name, roll number, and age. And if we want all the names of the names in the database, then it is vertical partitioning. Whereas if we want 3 people whose roll number is greater than 30, then it is horizontal partitioning. So let's focus on this 3 partitioning: range partitioning, hash partitioning, and round robin partitioning. So as I said earlier, let's first differentiate what is vertical versus horizontal. Vertical partitioning, the data vertically across all the processors. Each processor has a full number of records of a particular table. This model is more common in distributed database. Horizontal partitioning is a model in which each processor holds a partial number of complete records of a particular table. It is more common in parallel relational database. So let's see what is round robin partitioning. If there are n processors, now when we talk about parallel, there should be n processors. If you don't have n processor, how we will be working? So first we'll have in any partitioning technique, there should be more than one processor to compute things. So if there are n processors in the round robin, the ith tuple is assigned to the processor I mod n in the round robin fashion. Round robin partition is suitable for efficiently evaluating queries that access the entire relation. If only the subset of a tuple, that is example those satisfy the selection condition age is equal to 20, is required, hash partition, range partition are better than round robin partition. We will see it's in detail the example, but what actually it is like if first tuple will go to disk 0, second will go to disk 1, and third will go to disk 1. Again, if the fourth comes, then it will go to the first one. So, and now let's see what is the hash function. Hash function is applied to a selected field of a tuple to determine its processing. This is same like hash tables, which are created in data structures. We need a key attributes to, and on that key attributes, the data is divided. Adding the virtual hash partitioning has the additional virtual that it keeps data evenly distributed even if the data grows and shrinks over the time. Choose one or more attributes as the partitioning attribute. Choose hash function h with range 0 to n minus. Let I denote the result of hash function h applied to the partitioning attribute value of tuple. Send tuple to disk I. Now let's see what is range is. Tuples are sorted and n ranges are chosen from the sort key values so that each range contains roughly the same number of tuples. The tuples in the range I are assigned to the processor I. So serial ID 1 to 10 assigned to disk 1, 10 to 20, disk 2 and disk 3. Let's see what an example is. Suppose we choose an attribute, something as a partition attribute. Now the partition attributes, then we take it as a vector. Now what we do, if the value of that vector, suppose we have any vector which we have to assign, which processor it should assign, let it be a vi. So if the value of vi is less than vi plus 1, then it goes to disk I plus 1. And if the tuple with v is less than v0, it goes to disk 0. So tuple with v with the vi that is greater than or equal to vi minus 1 go to disk n minus 1. Suppose now here we have taken an example. Suppose the partition vector we have assumed it is 5 to 11. Tuple with a partition attribute value 2. As its value is less than 5 to 11, it will go to disk 0. A tuple with value 8. As this work comes in the vector 5 to 11, it will go to the disk 1. While the tuple with the value 20, it goes to the disk 2. So this is I have taken an example of database to get more in detail about this. There are 14 records about the name of the employee, his work grade and the department name. Assume that we have 3 processors, namely P0, P1, P2 and 3 disks associated with those 3 processors, namely D0, D1, D2. So this is a round robin fashion. I said as round. Now we have taken in this case that we have three processors, and now first records go into D1, second records go into D2 and third records go into D0. Similarly, fourth record go into D1 and so on. So after distribution of records, we get the following list. Now see here the first record is Smith, Blake and Ford. Now here also you see first is Smith goes in record 1. This is record number 2 which goes in the partition number 2 and this goes in the 4. So Smith, Blake and Ford. In this way round robin fashion is applied. See here we have 1, 2, 3 record 3. Again 4, 5, 6. We have time quantum as such the records are distributed. Now let's go next. So this is hash partitioning. As we said, we need some other attribute. So in our table we had a grade function, grade numbers, where grade is a value of grade attribute of a record and n is the number of partition, which is 3 in our case. So we put grade mod n. While applying the hash partition, we will get the following partition of the employee table. For example, grade of Smith is 1, while the hashing function is 1 mod 3. So the grade of Blake is 4. Directs to partition. So the grade of King is 5, which directs to partition number 2. So in this way, similarly, the different values are being put into different tables using the hash function. Then the range partition. The range partition here is like under a range partition. For applying a range partition, we need to first identify range partition vector. Now let us choose 2 to 4 as a range vector. So according to the vector value, less than 2 will go into the partition 0, greater than 2 and less than or equal to 4 will go into partition 1 and other values will go into partition 2 as depicted in the following table. So let's briefly see what is the comparison. It is best suited for sequential scan, round robin, and it is when equal number of tuples are there. But it also it is difficult when no clustering of tuples are scattered over across all the disks. Now hash partitioning, good for sequential access, good for point queries and partition attributes, no clustering, so difficult to answer range queries. Range queries provides data clustering for partitioning attribute values, good for sequential access, good for point queries for on partitioning attribute. Only one disk need to be accessed. For range query on partitioning attribute, one to few disks may need to be accessed. It has a problem of execution skew, because sometimes there may be this means that sometimes it may take more time than normal execution. So this I have been summarized in a table, so which will be very useful for you, and thank you.